Alright, we are live.
Hello, person watching this video.
Yeah, what are you recording this for?
Sarah's not in class, obviously, and she asked me to record it.
Sarah.
Here, Jared. Shh, calculator charge or Trevin off the plug in. Wasting energy, Trevin.
How's that my phone?
You're wasting energy. You grabbed your calculator?
I don't think I'm wasting it. If you touch the end, it's not gonna shock you.
Alright, here we go. Geometric probability. So the geometric probability is a probability that involves a geometric measure. A lot of times we're going to talk length and we're going to talk area. We'll do a little bit with length. With length we'll have number lines like this. Area we'll have shapes. We'll have like dartboards. Those are the types of problems we're going to do to start. So, probability for geometric probability is still the same. It's the number of favorable outcomes over the number of total outcomes. When we're talking about area, it's the area of the favorable outcome that we want over the area of the total thing, or the total area. If we're talking about length, it's the length of the favorable outcome over the length of the total number line, or the length of the total thing that we're measuring. Alright? So area, favorable outcome over total outcome. We got that?
Wait, no.
So, guys, I'm going to go a little bit quick because we have a lot of stuff to get through. We have a short class, so I want to make sure we get some work time. So I'm going to go a little bit quicker than normal today. So, geometric probability. Probability on a coordinate plane. So it asks us to find the probability of landing in the parallelogram. Well, let's start off with which one's a parallelogram?
The bottom.
The bottom one, right? It's got parallel sides. Very good.
I thought it was the top left
So,
one.
I'm going to find the area of not only the parallelogram, but the area of the whole thing. Let's start with the parallelogram. How do you find the area of a parallelogram? Ooh, this could be a sucker question.
Base
Are you saying high?
height.
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 Oh, height. Base times height is correct. Area equals. It sounded like you were saying hi to me. I don't know. So, base times height. So the area of the base times the height. So 1, 2, 3, 4. 4 for a base. I have a height of 6. Draw a straighter line than I did. Right? It's on a coordinate plane. I can just count the boxes there. So base of 4, height of 6 means I'm going to have an area of 24. Now calculate the area of the grid or the total thing.
100.
How big's our grid?
400. I don't know. Maybe not. 400.
How big's our grid?
100 times 4 is 400.
So
What? Is it 400?
it's 400, but how'd you get that? 20 times 20, right? My grid is 20 by 20. Anna, don't worry, I'll get you sucker. Just relax. 20 times 20 give us 400. Alright. So probability is going to equal the area of the favorable outcome or landing in a parallelogram, 24, over 400. Well, it's 6%. Right, if you want to leave it as a fraction, you can leave it as a fraction. It gets down to the 3 over 50. If you want to leave it as a decimal, you can leave it as 0.06, right? It doesn't ask you for a specific one. It does have percentage on there, so I'd like you to at least put that down. You can leave your answer as any of the 3. Any questions? Alright, next one. If you were smart, you would have been looking up the area of the trapezoid. So the trapezoid, the top right shape. How do you find the area of a trapezoid? Another sucker question.
Base 1 times plus base 2 over height times area.
Oh, you were so close. You were getting there.
Height times area.
Trevin, what do you got?
1 plus base 2 over
Length times half.
length times half.
Not over length times half.
Over base. Height times 2.
I like this part. Base 1 plus base 2.
Do I get a sucker for that?
I'm going to multiply by 2 other things.
Half and height.
Half and height. 1/2 times base 1 plus base 2 times the height gives us our area. Right? We want an average of the two bases multiplied by the height. Average of the two bases multiplied by the height. So my first base is 8, bottom base is 4. Once again, make a straighter height than I do. It should come out to 11. The height of our trapezoid should be 11. So if I plug it in, I get area equals 1/2 times 8 plus 4 times 11. Well, 8 plus 4 is 12. Times 1/2 is 6. Times 11 is 66. So the area of my trapezoid is 66 square units. What's the area of my grid? Has it changed?
No.
No, it's still 400. So, area of the trapezoid 66 over 400 gives us what percentage?
16.5.
Approximately 16.5%. Good. That's a probability of randomly landing in the trapezoid. Any questions? Alright, let's keep cruising. Probability with geometric shapes. In this case, we stuffed a circle into a square. Alright, we're told the circle has a radius of 10. Put that on there. The square has length of 20. What's the probability of a dart thrown and land inside the circle? So my favorable outcome would be
The area of the circle.
area of the circle. Well, how do you find area of the circle?
Pi r squared.
Pi r squared.
Do we all get suckers?
You do not all get suckers. That one was too easy. So it should be 100 pi. Do not multiply 100 times pi right now because you have to round and your answer will be off once you divide then. Wait until we do that final calculation to put that in your calculator. Alright, so we should have 100 pi for the area of my circle. Then I need the area of the total shape.
400.
400, right? It's the area of the square. So 20 times 20 is 400. Now is when I would do 100 pi, and then divide it by 400. So I don't have to round it. We should get approximately 79%. Awesome. Or you could have reduced your fraction. Any questions? No? Alright, keep cruising. Example 2. You flip-flop them. I put the square inside the circle. Change the dimensions a little bit. Square has a length of 15 inches. Circle has a radius of 7.5 times the square root of 2. So? 7.5 times the square root of 2. How would I know probability that the dart is thrown inside the square? Well, what's my favorable outcome? Hitting the circle or square?
Square.
The square. So I need the area of the square on top. So 15 times 15 is 225 over the area of the circle. So that's going to equal pi times 7.5 squared to 2 squared. Well, what's 7.5 times square root of 2 squared?
112.5.
112.5. And I'm going to have that times pi. Alright. Any questions so far? That is my total area. That's the total circle. So 225 divided by 112.5 pi should give us about 64%, Trevin says. Do we agree?
Yeah.
Awesome. Any questions? Nothing? Okay, we'll keep going. Geometric shape still. Now we're talking about like a dartboard. Probability that a dart is thrown at the board will land anywhere inside the middle circle but not the bullseye. So we want to find. The diameter of the bullseye is 4 centimeters. The radius of the middle circle is 6 centimeters. The radius of the outer circle is 10 centimeters. First thing it's asking us to do is calculate the area of the middle circle. So, what's the area of the middle circle, or excuse me, the radius of the middle circle? 6, right? The middle circle is the blue one. So, the area is pi r squared, so 6 squared pi, or 36 pi. Now, Martine, what is the area of the bullseye? The radius is 2, so the area is 4 pi. Good. Right? It says the diameter is 4. We got to be careful. So the diameter would be 4, but the radius of that red part would be 2. We got to be careful. So calculate the area of that bullseye would just be 2 squared pi, or 4 pi. Now, it wants us to calculate the area of our favorable outcome. What did we say our favorable outcome was?
The middle circle minus the bullseye.
The middle circle minus the bullseye, right? We just want the blue part. We want it to land inside the middle circle, but not the bullseye. So I want just that blue part. So, how do I figure out how big that is? Hey, what'd you say?
The middle circle minus the bullseye.
The middle circle minus the bullseye, or 36 pi minus 4 pi. So that blue part is 32 pi. Alright? Calculate the area of the total outcome, or of the whole stinking thing. The whole big circle. How do I do that? Aaliyah. Okay?
Why did you do the radius of the bullseye as squared when it says 4?
It says the diameter is 4.
Oh,
Right?
okay.
Alright, how do I find the area of the total outcome?
Use the outer circle.
What?
The outer circle.
Use the outer circle. It says the outer circle's radius is 10 centimeters. So all the way out to here is 10. So I know area equals 10 squared times pi, or 100 pi. So now if I want to do the probability, I'm going to take my favorable outcome, which I found out was 32 pi. I'm going to put it over my total, which is 100 pi. I'm going to get 32%. Right? Pi's cancel out. I get 32 over 100. Turns into 32%. Which I believe comes out to 8 over 25. Any questions? Trace more. Trace Moss. Geometric probability with line segments. So this is what we're talking about when we're talking in length. So it's going to be our favorable length over our total length. If I look at the first one, line segment AF. What's my total length?
18.
18. It goes from 0 to 18. So my total length is going to be 18. Now I want to find the probability that is on the indicated line segment if I choose a random point. So I need to find the favorable length, or the length of AB. A to B, from 0 to 2, is going to be 2 over my total of 18. So 1 over 9. Or I think it's 11%, approximately. The second one, I need to find my favorable length, or the length of BD. So 2 to 11. It's going to be 9 over 18, which is 1/2, or 50%. The last one, BF. Find the length here. From 2 to 18. Be 16 over 18, or 8 over 9, approximately 89%. Any questions on that? Do we need to do the second line segment?
No.
Can we skip it?
Mm-hmm.
Go to last problem?
Mm-hmm.
Alright. Last problem then is an application problem. You work for a temp employment agency. Your city is split on the east and west side by a river. You live on the east side, or excuse me, west side, and you prefer to work there. The work assignments are spread evenly through that rectangular city. Find the probability that an assignment chosen at random for you is on the west side of town. How could I go about doing this?
Find the area of
What triangle?
the triangle.
What triangle?
The one in the picture.
The only one picture. The west side of town makes a triangle. Right? The side that you live and want to work on is a triangle. So if I find the area of that, that's my favorable outcome, right? That's where I want to work. So if I find the area of the triangle, or the area of my variable, I can put it over what?
The rectangle.
The rectangle, or the total area. So, area of my triangle is 1/2 base times height, or 1/2 times 1.5 times 2.25. I'm going to put that over the area of the total thing, or the total rectangle. Well, base times height. I have a height of 1.5 times what? 1.5 times what for the rectangle? What'd you get, Kelly? Kaylee?
2.25 plus 1.75.
2.25 plus that 1.75. We want that whole bottom part. So it's going to end up equaling 4. So I'm going to get us 1.6875 over 6, which comes out to approximately what percent?
28.
That was ugly.
What?
Approximately 28.1%?
Yeah. Oh, point 1.
Sure. 0.1. Or 28. Doesn't tell you what to round to, right? So, I'd accept 28. That's fine. Alright. So approximately 28.1 or 28%. Any questions?
No.
Awesome.